one's contributions are punished by taking away user deposits. Important to note that allowing advanced AI models and large datasets to be widely shared, updated, and trained could increase the rate of AI adoption and effectiveness. Let us now look at digital investment datasets traded by AI agents over blockchain. Blockchain is already used to store and trade financial instruments such as cryptocurrencies and security tokens. However, this is a nascent market that is only a few years old. Security tokens themselves are even more nascent. By one measure, the total security token market cap for January 2020 was a mere $52.7 million. AI will create and trade digital investment assets over high-speed private blockchains. Clearly, there is not enough activity and data to apply AI to financial products traded over blockchain yet, but it is evolving and evolving fast. As data volumes going through blockchains increases, AI can glean insights from data, help create financial products, and even trade these products autonomously. According to a presentation at MIT by Jamil Sheikh, CEO of Chain House, the blockchain AI convergence process will cover 4 stages as shown in the diagram. Stage 1, blockchain proof of concepts. Stage 2, tokenization of assets on blockchain. Stage 3, digital investment assets traded on blockchains powered by machine learning. And stage 4, AI as economic agents that trade digital investment assets and traded on blockchains. Tokens can represent underlying securities, physical assets, rights to cash flow, or utilities. Tokenizing and trading assets on blockchains reduces transaction cost and settlement time while improving auditability. We have already seen that in tokenization session, haven't we? AI and machine learning become applicable for pattern detection and predictive algorithms. However, we don't have enough on-chain activity to apply AI yet. The third stage will see the introduction of native digital assets. Tokens can go from representing an underlying asset to becoming the underlying asset. While this concept is hard to digest now, it will be held by the future explosion of complex blockchain data. This kind of financial engineering will create new revenue resources for financial firms. Applying AI and machine learning will create a competitive advantage for them. To be sure, these native digital assets will be highly exotic products. They will exist on blockchains and have their own economic behavior and unique cash flows. They will be created by either human or AI-driven financial engineering. Their risk, predictive, and pricing models will be AI-driven. These exotic and complex financial products might bring back memories of the asset-backed securities, CDOs, and credit default swaps that led to a 2008 financial crisis. Yes, the downside risk is there and these products must be regulated. Still, native digital assets are likely the next evolution of financial engineering and will see them eventually. The fourth and final stage will see AI become economic agents. AI algorithms will actively trade digital investment assets over a blockchain-powered tech stack. Evolutionary algorithms can generate, test, and trade multiple strategies, kill off underperforming strategies, and continually tweak the winning strategies to maximize trading profit. AI with minimal human supervision. In this new world, AI will create and trade digital investment assets over high-speed private blockchains. Institutional investors will buy these assets because they trust the ability of the issuing firms. This means that incumbent firms will have a huge advantage. This future might seem hard to fathom, and the details are necessarily vague because nobody has done this yet. However, the underlying blockchain technology and AI methods already exist. We simply need increased blockchain activity, improved AI capabilities, and corporate adoption. Remember, if you had told people in 2009 that everyone would be talking about magical internet money called Bitcoin within 10 years, you would have been laughed out of the room. Specific use cases for combined blockchain and AI will depend on company needs, but the underlying theme will be data. Blockchain will ensure that data is secure, private, and trustworthy. AI models will use this data to become more effective. For instance, an autonomous car company could store data collected by its car on a blockchain. When self-driving cars go mainstream, they will collect huge amounts of driving data from onboard cameras and sensors. This data is used to improve the neural networks powering self-driving functions. Storing this data securely and maintaining driver privacy is a business need. Storing this data securely and maintaining driver privacy is a business need. Storing data on blockchains can anonymize driver information, ensuring driver privacy. The car company can still use the data to improve its self-driving neural nets. From a monetization perspective, the car company could share aggregated and anonymized driving data with insurance companies. Insurance can then use the data to price self-driving car insurance more intelligently, since self-driving cars have a different risk profile than regular cars. In the end, driver privacy is protected, the car company improves its self-driving capabilities, and the driver may get insurance at a better price. Another small example I would like to share with you all, which you might already be aware of or already have seen it. When we type mails on Gmail, you must have seen Gmail trying to suggest next words, sentences, or even the greetings that you might be used to. When we type mails on Gmail, you must have seen Gmail trying to suggest next words, sentence, or even the greetings that you might be used to. How is it being done? Through something called federated learning that is different from distributed learning, which is being widely used at present. The objective of federated learning is to provide the means to train a machine learning algorithm on several local standalone datasets at different locations, can be called local nodes without transmitting or explicitly sharing the actual private data elements. The basic phenomena is to learn local and then extend the sharing of weights, gradients, and parameters at a certain frequency towards a global learning model connected to all local nodes. The primary differentiator between federated learning and distributed learning resides in the characteristics of the local dataset and how it is to be used. As distributed learning emphasizes at availing computing power through the distribution, while on the other hand, federated learning is built to train models in the heterogeneous architecture, and even the local datasets, unlike distributed learning, can be different and independent. In our example of Gmail, the algorithm comes to your local device, laptop or mobile, and update its learning using your data, and then goes back and update the central AI module. This way, your privacy is secured, and also your data never leaves your device, but only the learnings from it.